Alright, so you should have just finished filling out your unit circle with your right triangles. And so I'm going to show you what it should look like, and you should check your unit circle to make sure it's right, because if it's not right, it's going to mess you up for a long time. So this is what your unit circle should look like. And so it should be filled in exactly like this, these radians, degrees, and all these coordinates. And so I want you to just look at this for a second, push pause or whatever you need to do, make sure that yours has the same, all of these things, and make sure it's exactly right. Alright, so now, we said in the very beginning that the whole point of using this unit circle is so we can evaluate things like the sine, cosine, and the tangent. And so I want to show you how we're going to use this to evaluate sine, cosine, and tangent. And so there are rules that we're going to use every time that work for sine, cosine, and tangent, but I kind of want to show you where they come from. And so I'm going to look at this unit circle, and we know that first of all, sine, if you have ever seen this little acronym, SOHCAHTOA, this just means that the sine of an angle is the opposite over the hypotenuse in a right triangle. And so if we have a right triangle, here's our right triangle. If this bottom angle right here is my angle, then these legs are called certain things. The angle, or the side that's always across from the right angle, is the hypotenuse. The side that is across from the angle itself, this is the opposite, because it's not touching that angle anywhere. And then the adjacent, the word adjacent just means to touch, okay, or to be beside of. So this leg is the adjacent because it's beside this angle, okay. So these would be our three legs. Now if I were to take this angle and move it up here, the hypotenuse wouldn't change, but this side would become the opposite and this side would become the adjacent. So those would just switch. So I want to use, or think about this whenever I'm trying to find the sine, cosine, and tangent of any angle. Let's say that I look at this angle right here, and so I'm going to just draw my right triangle in that we just found. It's not the best right triangle, but we'll go with it. That would be my right angle. And so I said that the hypotenuse is 1, always 1 because it's the radius of the circle. And so if this is my angle, 30 degrees, or pi over 6. So let's say I was trying to find the sine of 30 degrees. This is also the sine of pi over 6. I would take the opposite, because that's what this little acronym means, sine, opposite over hypotenuse. And so the opposite would just be this leg, which I know that's just the y distance. So that would be 1/2 over the hypotenuse, which would just be 1. And so 1/2 over 1 is just going to be 1/2. And so the 1/2 is just the y coordinate. So right over here, when I'm talking about my rules, and this will always work, the sine of any angle is always going to be whatever the y coordinate is at that angle. And so I remember this a really, really stupid way, but my kids in class like it, and it helps them remember what the sine is. So in my head, I always go sine and really like draw it out, and then I say sine goes with y, and it just kind of sounds alike. I know that's kind of a stretch, but they remember it, and so if you remember it, that's really all that matters. But so in my head, I always go the sine is the y, and so that's what I used in high school when I couldn't remember the difference in sine and cosine. Now let's look at the cosine of that angle. So let's look at the cosine of 30 degrees. Now the cosine is just the adjacent over the hypotenuse. So the adjacent leg is just going to be this leg, which I know is just square root of 3 over 2. And then the hypotenuse is just 1. So square root of 3 over 2 is over 1 is just square root of 3 over 2. And so this is just the x coordinate at that point. So the cosine's rule is cosine is always the x coordinate. And in my head, I go cos equals x. And so it just works. So anyway, now last thing that we're going to do is the tangent. And the tangent is, so let's say we're doing the tangent of 30. Tangent of 30 would be the opposite leg, which we know is 1/2, over the adjacent leg, which is square root of 3 over 2. And we're not going to go through this math right now. I just want you to see what the rule is. This is basically going to be the y coordinate over the x coordinate. And so tangent's rule is just y over the x. And so, I hope my video wasn't in the way, but 1/2 over square root of 3 over 2. And so I had y over x. And there was that. Now, we'll come back to this later, but this little acronym I remember by saying, some old hippie caught a high tripping on acid. And it just works too. And everybody seems to like it. So, you may have heard that before, but if not, there you go. So, sine y, cos x, and then tangent is y over x. Now, there are 3 functions, so you've seen these 3 functions before. There are 3 more functions that you probably have never seen before, and those are called reciprocal functions. And so each of these reciprocal functions go with one of the previous functions. So our sine theta, cosine theta, tangent theta. By the way, in case you didn't know, this little theta symbol is actually spelled like that, and that's just a variable that you'll see used a lot to represent an angle. And so it's just a Greek letter, like you've heard of sororities and fraternities with like sigma, alpha, theta, beta. Anyways, it's just one of those Greek letters that are used real often for angles. So you'll see me use that a lot. But each one of the 3 original functions, sine, cosine, and tangent, go with one of these functions. This is cosecant. This is secant, and this is cotangent. Now, you can probably guess that cotangent goes with tangent, and it does. So tangent and cotangent go together. Now, the other 2 are a little bit tricky. I remember these and which one goes with which by saying each pair has to have a co in it. So, for example, tangent didn't have the word co in it anywhere. So it has to go with a function that does, and it goes with cotangent. Now, cosine already has a co in it, so it's going to go with the one that does not. So that means cosine goes with secant, and so they're a pair. Now, sine doesn't have a co anywhere in it, so sine goes with cosecant. And so now, the word reciprocal just means that you take a number and flip it. So if I had like 3/4, the reciprocal would be 4/3. And so for cosecant, the reciprocal is just going to be 1 over whatever sine was, and sine was y. So cosecant is just 1 over y, and that's the rule for cosecant. Secant goes with cosine, so instead of it just being x, it's going to be 1 over x, because cosine goes with x. And then cotangent, tangent was y over x. So cotangent is just going to be x over y. And those are our rules. And so I'm going to show you how to use these rules to evaluate. And evaluating is huge. Like, you need to be very good at evaluating when you go to calculus. And so we're going to do a lot of it. And you should practice a lot of it on your own. I've got a lot of links and stuff on Haiku that you can practice this with. And so you need to be good at it. Now, I'm going to show you how to evaluate the 6 trig functions for this angle. So what I'm doing is the sine of 5 pi over 4, I'm plugging that in for theta, cosine of 5 pi over 4, and the tangent of 5 pi over 4. And then we'll go on and do the other 3 after we do these. So all I'm going to do is go to the unit circle at 5 pi over 4. So I'm going to erase this now. So at 5 pi over 4, that's down here. So if I'm finding the sine, I'm finding the y. So the sine at 5 pi over 4 is just negative square root of 2 over 2. So this is just negative square root of 2 over 2. Now, the cosine, cos x, is just going to be the x coordinate at 5 pi over 4, which is just negative square root of 2 over 2 as well. So this is just negative square root of 2 over 2. And then the tangent, and I'm just going to write that point down. I know the point was this, so I don't have to keep flipping back and forth. Tangent is just y over x, and so I'm going to put negative square root of 2 over 2 over negative square root of 2 over 2. Now, you can look at this and just say, okay, I've got the same number over itself. So if I had like negative 3 over negative 3, that'd just be 1. So this is going to just be negative 1. Okay, or what you could do is take this bottom piece and flip it and multiply, and everything would end up canceling out. But it's easier just to think of it like that and make that a negative 1. Now, I'm going to go do the other 3. So sine goes with cosecant. I'm going to do the cosecant of, I'm plugging in 5 pi over 4. I'm going to do the secant of 5 pi over 4. And then I'm going to do the cotangent at 5 pi over 4. Now, cosecant is just 1 over the y, since cosecant goes with sine. So 1 over the y is just going to be 1 over negative square root of 2 over 2. And so I have to take this bottom piece, and since it's a double-decker fraction, anytime you have like a double-decker fraction, you've got to take the bottom, flip it, and multiply it by the top. So this is just going to be 1 times 2 over the negative square root of 2. And so the 1 doesn't really change anything, so 1 times this is just going to leave me with this. So this is what I have. And we cannot leave the square root in the bottom of that. So I need to do what is called rationalize. And this is something you should have done in Algebra 2. So that means take whatever's under the radical, square root of 2, and I'm going to multiply that by the top and the bottom. And so the good in doing that is you'll see what happens with the bottom part of this fraction. This is just going to be 2 square root of 2 over. In the bottom, I'm going to have negative, but whenever I do square root of 2 times square root of 2, the square root of 2 times the square root of 2 is just the square root of 4. And the square root of 4 is just 2. So it's really like I've got that. And so when I simplify this, these 2's are going to cancel, and that's just going to leave me with a negative square root of 2. So the cosecant, I'm going to write it over here so we can see it better, is just going to be negative square root of 2. Now, the secant is just 1 over the x, so that's going to be 1 over negative square root of 2 over 2. And I just did that same math for the cosecant. So I'm going to go ahead and just say that the secant is the same thing. It's just negative square root of 2. And then cotangent, I'm going to do, instead of doing y over the x, I'm going to do x over the y. And so x over the y is just going to be negative square root of 2 over 2 over negative square root of 2 over 2. And so I've got the same thing over itself, so it's just going to be 1. And actually this over here should have been a positive 1, because the negative divided by negative will cancel out. So that should have just been 1 for both of those. Alright, let's do some more. Okay, so I want to do the same thing for the angle 2 pi over 3. So I'm going to go back and find 2 pi over 3, and I'm just going to go ahead and write this coordinate down. So 2 pi over 3 is here. So negative 1/2 square root of 3 over 2. Alright, is my coordinate. And so when I do the sine of 2 pi over 3, sine goes with y, so that's just going to be square root of 3 over 2. The cosine at 2 pi over 3 is just the x, cos x, so that's just negative 1/2. And then the tangent of 2 pi over 3 is just y over the x, so square root of 3 over 2 over negative 1/2. Now, this is a double-decker, so I'm going to have to take this and flip it and multiply it by the top. So I'm going to just move it up to the top and flip it and multiply. Now, I'm going to go ahead and make this a little bit easier on myself. This 2 and this 2 are going to cancel out. And so, that's just going to leave me with the square root of 3 over negative 1. And so if you have a negative in the bottom of a fraction, it really just makes the top negative. So this is just negative square root of 3. Alright, and so then whenever we go to do the other 3, I'm going to move this over here a little bit. So whenever we go to do the other 3, sine goes with cosecant. So cosecant of 2 pi over 3 is just going to be 1 over the y. So 1 over square root of 3 over 2. So I'm going to take this and flip it and multiply. So 1 times 2 over square root of 3. And I'm about out of time, so I'm going to stop here, and then I'll finish this in the second video, and we'll go on to evaluate the other angles.